Greetings, interstellar wanderers. Prepare to be swept away on a cosmic odyssey like never before. I'm your guide through the Galaxies, Nebula Quest, and you've just stepped into another mind-bending episode of Space-Time, the ultimate portal to unlock the secrets of the cosmos. Today we're diving headfirst into the celestial spectacle, where the universe itself puts on a fireworks display that makes our earthly pyrotechnics seem like mere sparklers. Buckle up, stargazers, because we're about to unravel the mesmerizing mysteries of quasars, the dazzling stars that outshine entire galaxies. I'm Nebula Quest, your cosmic captain, and this is the journey you didn't know you needed. Get ready for a cosmic roller coaster as we venture into the heart of these celestial fireworks. Without further ado, let the exploration of quasars begin. Quasars are the brightest and most powerful objects in the universe, outshining entire galaxies and emitting more energy than 1 trillion suns. They are the blazing centers of active galaxies, where supermassive black holes are feeding on huge amounts of gas and dust, creating spectacular displays of light and radiation. But what are quasars exactly? How did they form and evolve? What do they tell us about the history and fate of the universe? And how can we observe them from Earth? These are some of the questions we're going to answer in this video. So buckle up and get ready for an amazing adventure into the cosmic unknown. But what quasars really are? The term quasar is short for quasi-stellar radio source because astronomers first discovered quasars in 1963 as objects that looked like stars but emitted radio waves. However, quasars are not stars at all, but rather the extremely bright cores of distant galaxies. The source of their immense luminosity is a supermassive black hole, with a mass ranging from millions to tens of billions of times that of the Sun, surrounded by a gaseous accretion disk. As gas falls into the black hole, it heats up and releases energy in the form of electromagnetic radiation, from radio waves to gamma rays. Some of the gas in the disk is also funneled away from the black hole in a highly luminous, magnetically collimated jet. The jet can extend for thousands or even millions of light years and can interact with the surrounding intergalactic medium, creating shock waves and bubbles of hot gas. The combination of the accretion disk and the jet makes the nucleus of the active galaxy shine so bright that it can be seen far across the universe, even when the rest of the galaxy is too faint or obscured by dust. In fact, the most distant quasar ever observed, QSOJ 313-1806, is located at a redshift of 7.64, which means that its light was emitted when the universe was only 670 million years old. How do quasars form and evolve? Quasars are thought to be the result of an event that triggers a huge amount of gas to pile onto the central supermassive black hole in the galaxy. Such an event could be the merger or interaction of two or more galaxies, the inflow of gas from the cosmic web, or the instability of the galaxy itself. Quasars are most common in the early universe, when galaxies were closer together and more gas-rich. The peak of quasar activity was about 10 billion years ago, when the universe was about a third of its current age. Since then, quasars have become less frequent and less luminous, as galaxies have used up or expelled most of their gas, and as the expansion of the universe has reduced the rate of galaxy collisions. However, quasars are not always on. They can switch on and off depending on the availability and rate of gas supply. A typical quasar may last for a few million to a few billion years, depending on the mass of the black hole and the amount of gas in the galaxy. During this time, the quasar may undergo phases of different brightness and activity, such as changing the orientation or power of the jet, or becoming obscured by dust or gas. When the quasar runs out of gas, it shuts off and becomes a dormant black hole, waiting for another gas-rich event to reignite it. Some of these dormant black holes may still show signs of low-level activity such as weak jets or faint disks and are classified as low-luminosity AGN. Others may be completely silent and invisible, except for their gravitational effects on their surroundings. What do quasars tell us about the universe? Quasars are not only fascinating objects in their own right, but also valuable probes of the universe. By studying quasars, we can learn about the formation and evolution of galaxies, the growth and feedback of supermassive black holes, the distribution and composition of matter and energy in the cosmos, and the history and expansion of the universe itself. For example, by measuring the masses and spins of quasars, we can infer how they grew over time and how they affected their host galaxies. By observing the spectra and variability of quasars, we can determine the physical properties and dynamics of their accretion disks and jets. By analyzing the absorption and emission lines of quasars, we can probe the interstellar and intergalactic medium along the line of sight and reveal the chemical and thermal history of the gas. By comparing the luminosity and number of quasars at different redshifts, we can trace the cosmic evolution of quasar activity and the star formation history of the universe. By using quasars as standard candles or rulers, we can measure the distances and geometry of the universe and test the models of dark matter and dark energy by detecting the gravitational lensing or microlensing of quasars. We can map the distribution and nature of dark matter and study the structure and evolution of galaxies. How can we observe quasars from Earth? Quasars are among the most distant and brightest objects in the sky, but they are also very small and faint compared to nearby stars and galaxies. To observe them from Earth, we need powerful telescopes that can collect enough light and resolve enough detail to distinguish them from other sources. Quasars can be observed across the electromagnetic spectrum, from radio waves to gamma rays depending on their emission mechanisms and the intervening absorption. However, not all quasars are equally bright or visible in all wavelengths. Some quasars may be more prominent in radio waves, while others may be more prominent in optical or infrared light. Some quasars may be obscured by dust or gas and only reveal themselves in X-rays or gamma rays. To observe quasars in different wavelengths, we need different types of telescopes, some of which are located on the ground and some of which are in orbit. For example, acryotelescopes, such as the Very Large Array or the Square Kilometer Array, can detect the radio emission from quasars and their jets. Optical telescopes, such as the Hubble Space Telescope or the James Webb Space Telescope, can capture the visible and infrared light from quasars and their disks. X-ray telescopes such as the Chandra X-ray Observatory or the XM Newton can measure the X-ray emission from quasars and their hot gas. Gamma ray telescopes such as the Fermi Gamma Ray Space Telescope or the Cherenkov Telescope Array can observe the gamma ray emission from quasars and their high-energy particles. By combining the observations from different telescopes, we can get a more complete and accurate picture of quasars and their environments and learn more about their physics and cosmology. Now, all this has led us to the conclusion that quasars are the most amazing and mysterious objects in the universe, and they have fascinated and challenged astronomers for decades. They are the ultimate manifestation of the power and beauty of nature, and they offer us a glimpse into the past and the future of the cosmos. They are the cosmic fireworks that light up the sky and inspire our imagination. Thank you for watching this video, and I hope you enjoyed it. If you did, please give it a thumbs up and subscribe to the channel for more videos like this. And if you have any questions or comments, please leave them below. I would love to hear from you. Until next time, stay curious and keep exploring the wonders of space and time.